Okay, Specialist Mathematics, Paper 1, Tech Free from 2023. We're going to do question 15, which is a mathematical induction question. So the sum of a geometric progression with n terms, with the first term is 1, the common ratio is r, is given by, prove this rule for all n part element of the positive integers using mathematical induction by completing the steps of the proof as indicated. So they've been really nice and they've scaffolded it out for us. The first part is just worth a mark. It was our initial step. So we want to show that it's true for n equals 1. We want to show that, don't we? So the left-hand side is going to equal r is 1 take 1, r to the 0, 1. The right-hand side is r to the 1 take 1 over r to the 1 take 1. So that's the same thing over the same thing, which is going to be 1, which equals left-hand side. Therefore, true. True for n equals 1. Right, I'm going to do weird there. Because this is essentially just r take 1 over r take 1. Now, they've given us assuming the rule is true for n equals k. So they've done our second step and they've given us the second step. And then we've got to do the inductive step. So the inductive step is we've got to show true for n equals k plus 1. That's our inductive step. So we're going to start by writing our required to prove. Our required to prove is 1 plus r squared plus r cubed plus dot 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 plus r to the n, to the k minus 1. R to the k plus 1 minus 1. So we've got to go all the way up. That's the kth term, such as indicated there. Then we've got to go to the k plus 1th. And that equals r to the k plus 1 minus 1 over r minus 1. That's what we're going to show. Now, not everybody, when they write this, includes this term. If you don't include that term, that's okay. You're going from 1 to the k plus 1th term. That's the important bit. So I'm going to start with my left-hand side, which is 1 plus r squared plus r cubed plus dot 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 plus r to the k minus 1 plus r to the k plus 1 minus 1. Oh, that was a mouthful, wasn't it? This is where we're going to do our substitution. This bit is this bit from step 2, from our assumptions. So that's equal to r to the k minus 1 over r minus 1 plus r to the, now here we can simplify this too, can't we? Because it's k plus 1 minus 1, r to the k. Now we've got this left-hand side, it's an addition, and we want to make it equal to this right-hand side, which is all over r take 1. So let's create a common denominator. So I'm going to multiply this by r take 1 over r take 1. This gives me a common denominator of r take 1, which is what I want on my right-hand side. And I've got r to the k minus 1 plus, expand this out, r to the k plus 1, because remember r to the k times another r, because that's r to the 1, take r to the k. Expanding that out. Now we can see here that this r take k and this take r take k are going to cancel, giving me r to the k plus 1 minus 1 over r take 1, which is my right-hand side. So I have proved what I wish to prove. And then our conclusion, remember our conclusion statement, is by mathematical, sorry, my writing is terrible, induction. It is true that, some sort of wording this, 1 plus r squared plus dot 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 plus r to the n take 1 is equal to r to the n take 1 over r take 1 for all n element of z plus. the notation on my N, just mirroring that from what was given in the question. Now, it was 1 mark to show that this, we're making sure though we please put it as left-hand side equals right-hand side equals, not equal equal. Now this was 3 marks to do the inductive set, that you've got your required to prove, you do your substitution in, and then you work it out so it equals, and then a mark for this. And that is question 15.